Hello, everyone. So, before we talk about air pollution, let's talk about the atmosphere a bit, what it's made of. So, it's a um, layer of gases that envelopes our planet and performs very important functions. It moderates our climate, it provides oxygen, it shields us from meteors and hazardous solar radiation. It transports and recycles water and nutrients, and it has a bunch of layers. We're just gonna discuss very briefly. So it's made up mostly of nitrogen and oxygen. It's 78% nitrogen and 21% oxygen. It has other gases, but in a very small amount. And we are beginning to alter the quantities of these gases with the things that we are doing on this planet. And we are releasing more CO2 than it's being taken up by the trees, and methane. So maybe you know, maybe you don't, but the Earth came about around long billions of years ago. But then there was about 2.7 billion years ago, there was oxygen that came around. So there was a stromatolite that released the photosynthetic organism and released oxygen in the atmosphere. And that's how life kind of expanded from there, and they did photosynthesis. So we are changing the amounts of these gases, which is starting to, affect our climate. So the atmosphere is layered. It has four layers, and these four layers, they differ in temperature and density and composition, what are they're made of. So the bottom layer, so we have troposphere, stratosphere, mesosphere, and thermosphere. So this bottom layer, troposphere, is the one that contains the air that we breathe. So it's the air movement that's driving our planet's weather. And it's thin compared to the other layers. Um, the stratosphere is drier. It's above the sea level and it's similar composition as troposphere, but it's drier and less dense. And there is little bit of vertical mixing. So once the substances enter it, they tend to remain there for a long time. And it also warms with altitude due to absorption of sunlight and UV by the ozone. The ozone layer protects living organisms from UV damage from the sun. So that's what I wanted to say about the atmosphere. And then now we can talk about the pollutants. So air pollutants are gases and particulate matter that's added to the atmosphere, and it can affect climate or harm people and other things. Air pollution is something that releases air pollutants in the air. So some sources of the pollution are natural. For example, when we think about outdoor air pollution, we tend to mention smokestacks, bleaching smoke from industrial plants, but there are natural processes as well. So, wind, wind blown dust. So this is showing fires, volcanic eruptions, and this is wind blowing dust from Africa to Americas. So wind blowing dust is a natural pollution source. Dust storms can happen naturally when the wind sweeps over arid terrain, but they're made worse by unsustainable farming and grazing practices that strip the vegetation from the soil. So if it's bare ground, it's more likely to have those effects where the dust is being blown. Volcanic eruptions are again unnatural and they release large quantity of particulate matter. We're going to talk about what that is as well. In addition to sulfur dioxide and other gases into the troposphere. Um, when in 2012 there was a volcano that erupted in Mexico City, that added to a lot the pollution challenges that added a lot to it because there was ash that was from the volcano eruptions that you could ground airplanes, destroy car engines. So it had a lot of health risks as well. And then the fires from burning vegetation emit soot and gases, and lots of forest and grassland burn in a typical year. They happen naturally, but humans can influence and make them more severe. So human activity also creates outdoor pollution. We produce many air pollutants. As with water pollution, air pollution we create with point sources, which are known sources, and non-point sources. Point source describes a specific location. We know where it's coming from, like a coal fire power plant. Again, non-point again, similar with the water. We do not know where it's coming from. It can be coming from a bunch of cars. So the pollutants are released directly from the sources are termed as primary pollutants. So for example, ash from a volcano, sulfur dioxide from a power plant, carbon monoxide from a car are all examples of that. Secondary pollutants are so when the primary pollutants react with one another and the atmosphere and form other pollutants, those are secondary pollutants. Examples of those are ozone, formed near ground level from pollutants in an urban smog, and the acid rain formed when acids form when the acid rain from the acid rain. So that also when pollutants react with water and oxygen. Residence time is the amount of a time of pollutant spent in the atmosphere before settling on the ground. So short residence times result in more localized impacts over a short period. Long residence times cause long-term regional or global effects. If you look on here, it's telling you local, regional, or if it's global and how long it's going to stay there. So these are the long-lived centuries. These are the short-lived. So it's kind of telling you which ones are long-lived and which ones are short-lived pollutants. So then there was a Clean Air Act. This addresses pollution. It funds pollution control research, sets standards for air quality, encourages emissions and standards for automobiles and other point sources or known sources. So the EPA, Environmental Protection Agency, sets a nationwide standard for key pollutants, how much of the pollutant is okay, and how to, they do monitor those and to make sure the air quality is where it's supposed to be, and if it's dropping, then they take measures to address that. So these are the 6 pollutants that they do um, monitor. State and local agencies monitor carbon monoxide and so mostly vehicle exhaust related and nitrogen oxides, particulate matter. So all these are being monitored, all these 6. So nitrogen oxides, volatile organic compounds. So what carbon monoxide is, it's a colorless, odorless gas produced by combustion of fuel. So cars do that, engines are biggest sources, and it binds to hemoglobin in our red blood cells, preventing it from binding to transporting oxygen. Nitrogen oxides is a family of compounds that includes nitric oxide, and nitrogen dioxide. So these are produced when nitrogen and oxygen combine during combustion in engines. And this contributes to smog, acid deposition, and ozone depletion. VOCs are carbon-containing chemicals and also emitted by vehicle engines and solvents. So that includes methane, propane, octane, and they can also contribute to smog. PM, or particulate matter, is composed of solid or liquid particles small enough to be suspended in the air. And it can be a primary pollutant, dust or soot from a fire, or secondary pollutant, sulfates and nitrates. Particulate matter is classified by size, so it can be very, very small to a little bit bigger particles. Lead is a heavy metal that enters the atmosphere as a particular pollutant, and it results of vehicle burning either gasoline or metal smelting. Ammonia is a NH3 is ammonia, and that's also a colorless gas with odor. And cleaning fluids usually have that. And NH3 is a in a gas form is a waste product of animals and chemical fertilizers. So all this is polluting our air. That's all I'm trying to say. So we have worked on reducing the emissions. So since the Clean Air Act happened, the pollutants have reduced dramatically. So even though the population is increasing, energy consumption is increasing, we still managed to decrease the pollutants. So this is kind of showing you the percent decline and the years. And then this is comparing it with the energy consumption, which has gone up, population has gone up, vehicle miles and traveled has gone up. So all these things, gross domestic product has gone up, but we managed to decrease the emissions. So how did we do that? So we used some technologies. It resulted from a policy steps of technology advances. So they use these scrubbers that remove the airborne pollutants from the smokestacks. And also leaded gasoline was also phased out, which dramatically reduced its level in the atmosphere. So they used a lot of technology to clean air, basically. So nitrogen oxide, so air quality has improved of those six criteria pollutants, and those do have a lot of risk to human health. And they have EPA has a standard quality standard, which is, what's the maximum concentration that's allowed in the outdoor air. So nitrogen oxide is a foul-smelling, highly reactive reddish-brown gas that contributes to smog and acid deposition. And tropospheric ozone, O3, is a ground-level ozone. That's a secondary pollutant created by a reaction of these two, VOx and NOx. So ozone is a stable molecule that can injure living tissues and cause respiratory problems. So um, these toxic pollutants, they pose health risks and they can cause, they're called the toxic air pollutants, and they can cause a lot of health issues like cancer and reproductive defects or neurological development. So a bunch of health issues. And these include the toxic air pollutants include mercury, VOx, and other stuff that's found in our things that we use. And health risks are obviously higher in urban and industrial areas like Los Angeles. So the reason rural areas they are exposed that there's a health risk is because people are exposed to pollution from sources like airborne pesticides from farms and industrial pollutants that drift from distant cities, methane, hydrogen sulfide, etc., from animal waste, because they have feedlots, they're raising animals, fumes from natural gas extraction sites. And then industries, obviously, industrial cities, they have, a lot going on, and that contributes to air pollution. And then I want to move on to smog. Smog poses health risks. Smog is a general term for a mixture of air pollutants that can accumulate as a result of fossil fuel combustion, especially over the areas with high automobile traffic like Los Angeles. So cities suffer from a specific type of smog called industrial smog. So this is industrial smog, and there is this carbon and sulfur combustion happening. There is a particulate matter in soot, and it's reacting with other things like sulfuric acid and oxygen and water vapor, and it's creating this industrial smog. So when the coal or oil is burned, some portion is completely combusted, forming CO2. Some is partially combusted, forming CO, carbon monoxide, and some remains unburned. And that's a release that's soot. And coal contains contaminants like mercury and sulfur that reacts with oxygen to form sulfur dioxide, and then that can go under a series of reactions that can create this smog. So most severe industrial smog happened in the United States. That was in the town of Donora, Pennsylvania. So that's located in a mountain valley. And one cloudy day, after air cooled down during the night, morning sun did not reach the valley floor to warm and disperse the cold air, and that resulted in temperature inversion, and it trapped smog containing particulate matter and from a steel and wire factory. And from that, 21 people died and 6,000 people became ill. That was half of the town. And there was another event that happened in London. That's a high pressure system settled over the city for several days, trapping sulfur oxide and particulate matter. And this also killed 4,000 people. And then estimates go up to 12,000. So the killer smog episodes are like those that happen in these cities. They then after that governments they started regulating emissions. They reduced industrial smog. Uh, but in countries like China, where there's a lot of production going on, India, Eastern Europe, coal burning and lax pollution control continues to result in industrial smog. I don't know if you guys know about the city New Delhi. There is a similar issue going on there. Smog does have a lot of health risks. So, something called photochemical smog that happened in Los Angeles here. It forms when sunlight drives chemical reactions between primary pollutants and atmospheric compounds, producing a mixture of 100 different chemicals. Ozone is the most abundant, and nitrogen oxide, dioxide gives the smog a brownish haze color. So, windless, warm, sunny days provide ideal conditions for a formation of a photochemical smog. This is showing you that there are different reactions, chemical reactions happening to create the photochemical smog. So nitrogen oxide or nitric oxide and VOx, they initiate a series of chemical reactions that produce secondary pollutants, including ozone, right here, and that's gonna create photochemical smog. So we can take some steps to reduce the smog, and the steps taken in California include restrictions on emissions from power plants, oil refineries, and other factories, regular vehicle inspections for emission levels. At this point, because we do have you know, um, cars that run on battery that are electrical, so it would be better to switch the vehicles to electrical vehicle. That's going to help a lot. Improve technology in cars that reduce their emissions. So that's what it's talking about. Getting an electric car instead of a gas car. So Los Angeles city, they started to reduce um, their air pollution by by putting in some efforts, and they targeted emissions from motor vehicles because air pollution spreads from place to place. It's responsible for pollution control to kind of move control that where it's coming from and etc. So even though LA drivers now burn 2.7 times more gasoline, smog levels have decreased since 1980s. But ozone levels, they are still in excess of EPA standards. So the photochemical smog has been reduced since the 1970s. This is what it's kind of showing you. And so this is the year, and this is the federal standard, and this is the maximum concentration. So it has come down. We'll talk about ozone depletion and recovery in a different video.